Hi everyone, this is Vijay and today we are solving an interesting problem. So let me quickly explain you what the problem statement we are solving. Let's say you're working in Amazon, right? Daily you know that a lot of data that is being generated from different stakeholders, internal or external both, either from finance team, HR team, sales team, marketing team, or from the customer because customer also places an order and that generates a lot of data, right? Now the thing is you're managing each and every data from the let's say ERP management software which is SAP, right? There is a lot of data and each team has to track that data. But we do not want to create multiple tools for each team to track that particular order or something like that. Anything in the different processes or workflows that are defined in the company related to the data. So what we can do. So understanding the data is very important, tracking the things is very important, but how we can do that? That's very hectic because the data is very complex. Flowmap solves this in two steps. How? So Flowmap basically gives you graph visualization. Basically, you can visualize your whole data. You can visualize your data at each step. Each team can follow the data, track the data at every step from the graph visualization that we provide, which I'll be showing you in the demo further in this video. And the another most important feature is basically the chat interface. You can just simply write a query, and from the whole data, you can get the information about any sales order, any invoice, any delivery, anything, any customer, just by one query that you will be submitting in the natural language. You will get the complete data. That data, the result you will be getting, it will be highlighted in the graph visualization. Right? Let me quickly walk you through the project, the technical part, and then I'll be walking you through the demo. Okay. So this is a flow map. Flow map is a graph-based order-to-cash process explorer for SAP data. Let's say for this we have the order-to-cash process that we have right now shown here. What is order-to-cash? So customer places an order, it goes to the sales order basically, and then you have the delivery, which will be picked up from the warehouse. The next step is to the finance team will basically create an invoice that you will be calling as billing document in SAP. And then in the later step, the accounting team will be creating a journal entry and then the payment will be cleared by the customer. Let's say in any step is broken, right? Let's say finance team forgot to create a billing document or an invoice and the product reached to the customer. You cannot tell the customer to pay the money because you have no proof, right? Your finance team has not generated the invoice, right? So that is something anything can break in between, right? And there can be a lot of loss for us. And that's how the flow map basically comes into the picture and solves everything for you, right? So the technical thing here is it visualizes the full business chain. Customer places an order, order gets delivery gets billed, billing post to accounting, payment clears the entry as an effective graph and lets you query that data in plain English letter through a chat interface. Any team, no technical understanding required. Any team, finance, HR, sales, marketing, any team can just query, find the data of any customer, any invoice, anything just by one query, right? And visualize them. So how? Let's come to the technical part quickly. So data modeling and series. So I have the SAP data that was given to me, and that data I have modeled in a particular way. I have used Supabase, which is basically uses Postgres. So the raw source data, which was I got in JSON L file, and across 15 different entity types I had. The first challenge that's SAP splits what we think of a customer across. So there were a lot of folders like business partners and different things, but that are all related to customers. So I just created a customer table for that, and this is how we have basically modeled it into different 12 tables we have. Right, I will not go into that depth, but the important things only I will highlight. While feeding the data into the database, I have two things. I have flow status on sales order. We have different status. Basically, a healthy status means where there is no uh, broken step in the entire flow of a particular sales order, right? It has perfectly gone from the customer to sales order, then delivery, then invoice is perfectly generated, journal entry, and payment. So everything is perfect in that. But if anything is broken, then we have classified that based on different basically status, healthy, warning, critical, like this. Okay. So this is basically done on the seeding time itself, right? Now graph edges is an important part. Graph edges basically is for the predefined relationship that we are going to, create for our reference for later creating a graph for edges basically, right? So between the entities, the relationship, right? So that's why the graph edges were there. You can go ahead and read in the readme file. Okay, so I'll share the repository link, so you can go to the readme and read to know more in depth about it. Okay, so yeah, so that one data quick worth noting here is some payments, yes. So that's what I'm telling. The some records are broken. That's what we have flow status for. But the relationship, the edges, we are handling it properly. How? If let's say billing document created and direct payment is done without any general entry, but that issue is already handled. How? It will be handled in the similar way like in any other edge in the graph, right? We are not adding something additional to it. The graph will basically have a billing document and directly it will be pointing or have an edge toward to the payment instead of journal entry, right? Because we don't have any journal entry connected with this particular billing doc, right? So this is how it was handled during the seeding time itself, right? Architecture is simple. We are using Next.js. We have this graph canvas. We are using React Flow library for it. There's three routes we have basic. One for exploring the graph, one another for initial load, creating the graph. Then we have this chat, which basically uses this service pipeline, right? Database choice, I have used Postgres because the data and entities are predictable. We don't have very complex data, so that's why I have not gone towards the Neo4j because it will just add the complexity. That's it, right? And apart from it, we also need to have this LLM pipeline needs to handle the other query language also because Graph database uses different query language other than SQL. So that's why this basically is perfect database choice based on the complexity on which we were working, right? The data set that we had. Apart from the graph tables traversal, so initially 20 IDs, sales order IDs we are loading. Why sales order we are loading initially? Because we are loading based on sales order actually. The reason being, if we load it based on the customer can have a lot of history of the sales order. And if we load all those sales order related to the customer, we will not be able to show this complex data in the graph, right? So we will be later we will be adding things like pagination or something like that to so that user can click and load the new data apart from what is initially loaded. But right now we are just moving ahead with the this 20 IDs from the sales. This is basically this API is basically for expanding or when you double click it gives you the detail and all these things, right? It loads neighbors, right? LLM pipeline, we have two calls. First is basically natural language to SQL. Once we get the SQL, we will execute it, we will get the data, and again we will convert the data into the natural language. So this is basically for that. And also we are handling the guardrails and everything. We are ensuring that we only run the select statements and not the insert, update, and delete statements on the superbase, right? So we are handling everything from the prompt. So here is basically we have this prompt. We are using different techniques, few shot, zero shot, chain of thoughts, right? And we have defined everything, guardrail examples and everything we have defined, right? Node highlighting basically once the let's say you have mentioned some query from the chat interface, you get the result and that node will be highlighted. So we have also handled that. We are passing the node ID along with the results and conversation memory also we are having. So last six messages it goes from the front end only. Then it will be added to the prompt and yeah. So this is basically the memory project structure and this is how you can set up things. Limitation is basically right now we don't have any upgraded version for the doc today, but later we will be scaling. So initial, yeah, always we are having this 20, but you can double click and you can expand the graph. Now let's move to the demo quickly. Okay, so this is basically our whole data. So right now we have this 20 sales order for this particular customer. Right now it's highlighted because let me load it to show everything from scratch. So our graph is loading. This is the initial message from the chat interface we are getting. Ask me anything about your SAP order to cache data, and this is our data loaded for this particular customer. So from this customer, we are placed in sales order and that is being fulfilled by the delivery billed as a billing doc. This is the invoice and this is basically direct payment because we don't have any journal entry for this, but we do have a journal entry later. This okay. So basically, there is another edge we have for this particular uh, delivery, which is present at the bottom, right? So which is present here, and from here we have a journal entry for that sales order. So if we go up, you can see this edge is coming upwards, and here is that sales edge, and you can see this payment ID is present here. So this is linked to this, right? So this is the complete flow for a individual sales order, and similarly we have this complete flow for other sales order also, and for different customers, right? Okay. So when we click on it, we can get the detail. This is the sales order. This is if the total net amount. The status is healthy means nothing is broken in between, right? And this green basically dot here signals that it is healthy. We have different colors also for different status. Now let me use this query interface. Let's query something like uh, let's say give me track the complete chain for sales order 747400509. Let's see what we get. You will see here things will also get highlighted, so keep an eye on that. Yes, you can see. So we get this result. The sales order base has a total net amount of 229 and is associated with the delivery this. Although it was initially cancelled or something like that, but we can see the complete loads are highlighted which are involved from in the response. So the sales order, the delivery, and you can track everything for this particular sales order. And this is highlighted in the graph also. It gave you everything, the everything in this particular small answer, every data you need, right? So isn't this awesome? Like you have 10 million records. What you can do, you can just query here that I need this particular record by name, by any invoice number. Does not matter you belong to a finance team, does not matter you belong to an accounting team. If you know the journal entry, you can just name it. And you can tell I want to know the customer name to which this particular journal entry belongs. You don't have to go and deal with the complex data of 10 million records. You can just query here, and it will just give you the exact customer name and all the details. And here also it will give you, and it will highlight on the graph as well, right? So this is something which we are solving, and I hope you like it. So let me know your thoughts on this. Yeah, and thank you so much for watching. Thanks.